Hello everyone, welcome back to the channel. This is our second video on DP series. So in the first video we have discussed in detail about 1D DP primarily, about 1D DP and how you particularly move from recursion to memoization and also to the iterative DP or tabulation method. So if you haven't watched the video and don't know this concept, then it's recommended that you watch the video in the first DP video and then come to this one. Otherwise, in today we will do 3 Leetcode problems. All are medium level. So in the first day we did only very easy level problems. But if you follow these steps, if you follow the exact same steps, the exact same strategy I told you in the easy problems, these problems will also look really easy to you. So let's just start and yeah, that's all. Let's just start solving the problems. So we have this first problem, house robber. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stats. Only constant is from you is robbing each one of them. Is that the adjacent houses have a security system connected? It will automatically contact the police if the adjacent houses were broken on the same night. So you cannot rob any 2 adjacent houses, and each house has the nums of I amount of money. So how much is the total amount of money that you can actually rob? Okay. So, but first, if you look at this problem, if you first look at this problem and try to think, thing which you will see is that you are having an array. You are having an array, which is nothing but the houses. So let's say you are having 2, 6, 8, 5, something like this. 2, 6, 8, 5, 3, and you are having this. Okay. So you might think something like, let me rob this 2 first. At first, if you don't know DP anything, just you might be thinking to solve it in some greedy manner, but greedy fails here. You should not do here. Why? Because suppose you might be thinking in this case, if you are robbing 2, then you are robbing 8, and then you are robbing 3. So you are incurring a total of 2 plus 8 plus 3, which is 13, which is maximum. But in this case, it is happening. But if you check something like you have some number which is small, then you have some number which is very large, but then you are having some number which is even larger, okay. uh, so what you might think is that uh, in a greedy method, the first thing which will come to your mind is that I should pick up the largest number. But if you so in order to pick up the next largest number, you might be skipping this one. But if you pick this number, you cannot pick the large number which is more large and which is next to it, right? So you should pick this 2 and this 64 also. Okay. By indices also, you cannot do greedy. You cannot say that I will necessarily pick up the first index, because let's say you have something which is very large, which is immediate to the first index, okay, which is very large, and then you have something like this. Okay, so you cannot say that I will pick up the first element, then you cannot pick up this next element, right? So in a way you need to predict the future. Which is not possible, which is absolutely not possible. So the greedy method, the first idea which will come to your mind is that the greedy method fails terribly here. So the next approach which will come to you is DP. And in this kind of problem, it should be intuitive to you that we have two ways. Okay, we have two ways to do. Either I will go to a house. Suppose this is a house, this is a house, this is a house. I will see all of the house, okay, and take a decision whether take or not take. Okay. So this is also known as famously take not take DP. It is very helpful in solving subsequences type of problem in strings also. And even if when I will discuss about the knapsack DP, then also things like this is very much useful. Thinking the DP in this pattern is very much helpful. Okay. So in the take not take DP, what you do, you go to each one of the houses and you see what will happen if I take. What is the amount which I will get if I take this, you calculate that amount. Then you calculate the amount. What will happen if I not take this house? Then you calculate the amount. Then what you do, you since you want to maximize your profit, what you do is do maximum of take and not take. Just return maximum of take and not take. And in DP, you follow here also the exact same pattern. You can follow. You first start from recursion, then you go to memoization. Like you store the value in a DP array where the value is first initialized to -1, all of the values first initialized to -1, and then iterative. Okay. And then iteration or the tabulation, whatever. Okay. So let's solve this problem. Let's see how can we solve this problem. I will show you all the three approaches: recursion, memoization, and also iterative. So let's just start quickly. So what you do here is we write another function which is solve, but how you return is you return some function which will take these nums and say that if we start from index 1, this is nothing but the state of the DP. You need to have a state, right? So if you start from index 0, how much can you rob at max? Okay, if you start from index 0, how much can you rob at max? This is what you will be told to find in this solve function. Okay, so this solve function is very simple. It just takes this vector of integer nums and this integer index. We are starting from index 0. Okay, if I have exceeded n index, let's say nums.size is nothing but n, right? And if this I is currently 0, if it somewhere exceeds n, what I will do, I return 0, because if I go beyond the last house, I don't have any house, so I don't have anything more to loot, right? I don't have anything more to loot. I will not go back to my previous houses to loot any further. Okay, in the current house, I will take two decisions. I will loot the house, that is, I will take the things present in the house, or I will not take. Okay, what will happen in both of these cases? If you try to think that what will happen is that if you take the thing, you will definitely have this reward with you, nums of I, because you have taken it, you have taken the reward, and you cannot go to the next index. What you can do is go to the index which is +2, right? You cannot go to the index which is +1. You need to go to the index which is +2. So this I +2 takes care that no adjacent index is robbed. Okay, is robbed. Okay. Now, if you not take it, what will happen? If you not take it, you will not get any nums as you got in the previous one. Only what will happen is that you will be allowed to rob the next index also, I +1. You will go to the next index and tell me that from here onwards, what is the best that I can rob? What is the best that I can rob? Now after robbing everything, returning everything, I have the current decision with me whether I will take or not take. Now, whichever decision will give me the maximum value, I will just do that. Whichever will give me the maximum value, I will just do that. Okay, so it's quite simple. Let's try to run it and check. It's a recursive solution, so it should give TLE. We do have the accepted thing, but if we submit it, it should give TLE. Oh, so yeah, it does give a TLE. You already know why it does give, because the recursion tree has the number of nodes which is of the order of 2 to the power n. Okay, so many nodes are duplicate here. So we try to reduce those duplicacies by having a DP array. Okay, by having a DP array. This DP array, let's say, will always be initialized with -1, as I told you in my previous video already. And this vector integer DP will be passed here. It will be passed here also. And it will be passed here. So you have the vector integer DP. Now, if you have not have anything stored in the DP, if DP of I, this -1 represents the that index is empty, right? So if it is not empty, then return that index without doing anything. If it is not empty, do not disturb that. I will tell it this. Okay. And if it is empty means you reach here and you do all the take not take here, you save the state. You save the state. Okay. You are just saving this state and you are returning this nothing but dp of I. You're just returning this dp of I. So you will see here it is like you are catching the stuffs in my DP array, which acts as a catch memory while memoizing. So this is nothing but recursive DP. Is quite simple, quite easy to do. Yeah, so no declared identifier n. So let's have an n here. So you see it's the exact same recursion code. I did not do much. I just made a cache memory. That is all. And I just saved the things in the cache. Now you see from TLE, we do have the accepted thing. We do have the accepted thing. And as I told you in my previous video, that for online tests, for online examinations, this much is sufficient. You can go home by doing this. But what if this is asked in the interview? They may ask you to solve it in the iterative fashion also, right? Because that's the most optimal one. So what you will do in that case? What you will do in that case is also very simple. It's really simple, as I told you. First thing which you need to take care is that what will you do if you reach the end of the array? First, handle the base cases. Handle base cases. Okay. So here the base cases was greater than equal to n, right? So we need here an n plus 1 to says that dp of n is nothing but 0. Okay. Where dp of I denotes starting from how much can you rob starting from index I. Okay, how much can you rob starting from index I? DPI denotes that. So starting from the house which does not exist, starting from the end of the array, you can rob 0 houses. And if you are in the last house, starting from that till the end, there is only that house. So you have to rob that one only. So these are the base cases. So why did I do 2 base cases? Because you see, in this iterative formula, we have I plus 1 and I plus 2. And as I told you, we will go from the backward. And we need 2 of them, I plus 1 also and I plus 2 also. Okay. So what we do, as we need I plus 1 and I plus 2, I will start from n minus 2. Okay. I will start from n minus 2, I greater than equal to 0, I minus minus. Okay. Simple. That's easy. That's quite easy. What we do is copy the recurrence next. It's very simple. Just copy the recurrence. What did I tell you here? So what you need to do, dp of I is nothing but you take the maximum among these nums of I. I'm just copying whatever I've done earlier, nothing else. And this dp of solve, I am replacing it by dp solve of I plus 2. Okay, and also I plus 1. If I'm doing I plus 1, then I cannot take anything. And it's nothing. You just return dp of 0. Why 0? Because starting from 0, that's what it asked to me in the question. Starting from 0, what is the how much you can rob starting from index 0? Okay, that's all you need to do. Let's try to run it and check if there is any error. So you see, we do have the accepted thing. Let's try to submit it. So see, we do have the accepted and we have 100% right time complexity. Our memory is also quite good. So yeah, that's all for this. Let's move to the next question and check how we can solve this. Okay, let's move to the next question, house robber 2, which is very similar problem, very similar stuff. Let's check. House robber 2, you are a professional robber. The same thing is there. Here the houses are arranged in a circle. This means that the first house is the neighbor of the last one. Okay, so what does it say in the next question? So what does it say for question number 2? This time you are given a circular array. You have to do the same thing. You have to rob houses. Okay, you are given the task of helping a robber. Okay, so you have to rob houses. This time the houses are present not in an array but a circular array. But the first and last element, let's say starts from 0 index of the array. This is 1, 2, 3, 4. So you are given a 5-length array. If you are given a 5-length array, then the 0 and the 5 are adjacent to each other. So what does this mean? This means that if you can rob this, you cannot rob this. If we can rob this, you cannot rob this. So it is equal to saying that, it is very much equal to saying that if you rob from the first, if you are robbing the first, you treat the array as if you are the array is exists till n minus 1, only n minus 1 elements, that is it exists till n minus 2th index, and n minus 1th index, that is the last index, does not exist. It does not exist because you cannot rob that, right? Now if you are not robbing one, you can take again you are asking yourself whether you will take the first house or not take. If you not take the first house, you will start from index 1, and this time you can go all the way till index n minus 1. You can rob the last index also if you are choosing not to rob. Now this problem, you see, now this problem essentially reduces to house robber problem. So this house robber 2 problem also reduces easily to this house robber problem. Okay, reduces to the previous problem. How does it reduces? We have two things. We can treat this whole thing as a previous problem by removing the last element, and by removing the first element also I can treat this as a previous problem. Okay, so that's all you need to do. Let's try to quickly copy the code from the last problem and see how we exactly do this. So what we'll do is copy the code. This code will give me to rob houses, right? So this thing I will just copy it. I think I copied wrong. I did not copy this function definition. So yeah, I did it now. Let's change this ROVV. Okay, because it will have the same otherwise. So what I told you, I can rob either from index 0 to n minus 2, remove the okay, or rob from index 1 to n minus 1. Okay, in the last index also. So what you do is very simple. It's very easy, very simple. What you do is you go to the first index, go to the first vector, you do some duplicate, do some duplicacy. So what you do in this duplicacy is that you pop back the last element. That is, you are removing the last element in nums2, and you remove the first element in nums1. So pop front doesn't work in vector. If you know, what works is this dot is, and this takes an iterator. So what iterator does it take? It takes begin. I want to remove the first element. This will definitely have an O of n runtime complexity. Okay? This will definitely have an O of n runtime complexity. Now what I will return is very simple. I will either use this rob function. And I will feed two numbers. I will feed this nums of 2. You can either rob this way, or you can rob this way also, nums. But whichever will give me the maximum one, give me that as the answer. Okay. So you are saying that you rob in this array, rob in that array in the same way exactly, so that the circular condition is taken care of, and you just give me the maximum among those. It's very simple, very easy, very intuitive. So you just submit it and check if it works. We do have the accepted thing. Let's try to submit it finally. We have a runtime complexity error. So what is happening here? Let's try to check. Okay. The thing is that I am accessing two elements. But what if you see the last executed input is 0 only, right? So what if the nums has only one element? Just take care of that. If nums dot size equals to 1, if there is only one element in nums, what you will do? You don't have any choice but to return that only, right? What is the maximum you can loot? You return that. You return the only element which is present. So let's try to submit it now if it works. Let's see if it's giving any error or not this time. So yeah, this time it does not give any error. It gives instead the 100% runtime complexity. Yes. So that's cool. We do have two problems solved, two medium Leetcode problems. All of this you note is of 1D array, but these are quite famous problems, so that's why I'm just showing you the solutions to this. You must know these patterns in your mind. We will go to the next question now. We will go to the next question. Delete and earn. Okay, delete and earn. So what you do here is you're given an integer array nums. You want to maximize the number of points you get by performing the following operations any number of times. Pick any nums I and delete it to earn this. Afterwards, you must delete every element equal to nums I minus 1 and nums I plus 1. Okay. So you can also follow the same thing. You can also follow the same thing, recursion, memoization, everything. But I want to do it in a different way. It in much smarter method. Okay. So what I'm talking about, let's try to see, let's try to understand and see. So first of all the thing, if you are doing these kinds of problems in DP for the first time, you should definitely solve this question also, this delete and earn, whatever this problem is, delete and earn. You should solve this problem also by recursion first. You should solve it, do recursion first, then you do for memoization. You go for memoization as I told you, and then you go for the tabulation. Then you go for the tabulation method as I told you. But the thing here is that you should do this and write the code in the comments. Write code in the comments. Okay. You should definitely do this on your own and write the comments, because it's the same thing as I've told you. Just little bit of changes. What you need to do is that let's say you have some elements 2 2 2, you keep on taking them. Okay, you keep on taking them, and if you have 3 also, you just sort the array. What you will do is just sort the array and keep on taking these 2. Let's say take not take thing you will do. If you take all these 2, you cannot take these 3, so you need to remove these 3 also. So while this index you have taken, if the +1 value is present, you just keep deleting them, and then you have taken it or not taken it. So that's the same thing, is the exact same thing. For now I want you to think in it in a different way. For now I want you to think differently. Okay, why what is the benefit of thinking differently? Both will give you the right answer, right? But you will have a short solution, you will have a short code. You will have a short code, the most optimized version, that too in tabulated form. The hint is, I will give you a hint. Pause this video and try to think. I will give you a hint. Try to burn this problem down. Try to reduce down the problem. Reduce the problem to house robber case. Okay. Problem to the initial house robber case which I told you. How will you reduce this problem? Okay. Try to think it. Pause the video and then think it, and you just try to think for just like 3 to 4 minutes, then keep watching the video. Okay. So let's see how to exactly do this. Okay. So you have some array here. First you need to sort the array. Why sorting? I'm telling you, because it will keep us. So if you are having nums of I, you are having some nums of I element, the +1 value and the -1 value, if you want to keep track of that, so it's better if you sort it, right? If you want to keep track of that, it's better if you sort it. And if you are sorting it and going from left to right, you are going from I equals to 0 to I equals to n-1. You don't need to take care of this -1 even, because that you have already left behind. That -1 you have already left behind. All is remaining is this +1. Okay. So what to do here? How can you reduce this to house robber problem? Now you see in the house robber problem also, the indices were constrained that if you are looting this I, you don't loot this I +1 and I -1. If you are looting this I, you cannot lose the adjacent. But here it's the word which is there. Now you also check the constraint of this problem is nothing but the word. Where are the constraints? The constraint of this problem gives you a hint that this is 1e4. The constraint is 1e4. So you can solve definitely in the linear time of this. You can definitely solve it in the linear time. So what you can do is that you can essentially view this problem as you are arranging numbers 0, 1, 2. These are not the indices, but the value. but the value. Let's say you take 10 to the power 4 plus 1. These are the value that nums can have. These are the values that nums can have. Okay. Now let's say nums is actually having the values, which is nothing but, let's say 2, okay, 5, 5, okay, 6, 7, 7, 7, 8, 8. Let's say you are actually having these kinds of values. Okay. So you treat this whole thing, this n1e4 plus 1, as some values. These, let's say these are houses. I told you to reduce to house robber problem, right? So look it in this way, that these are houses and they have values. So if an element, see, if 0 is present, is 0 present in the array? Okay, it is not. So the value is 0. You write the value here. Okay. Is 1 present in the array? No, the value is 0. Is 2 present in the array? Yes. How much value it gives you? It gives you 2. Okay. Similarly, if you ask yourself, is 5 present in the array? Yes. How much times the value it gives? It gives 5 plus 5. It gives you 10. Okay. It gives you 10 coins. So you write the 10 here. So you make an array. You make a different kind of array with these indices and store what is the value that each of the value is giving you. What is the value that each of the value is giving you? 6 is present, it gives you 6. Okay, it gives you 6. 7 is present, 7 gives you 3 sevens, which is nothing but 21. Remember, this is nothing but 21. So it's quite simple, it's quite easy. You can see. And you can apply the same house robber concept now in these houses, right? If you can rob this 6, if you are looking to rob this 6 and gain this thing of 6, you cannot rob the 5 and 7. Now it is the exact same as the house robber problem. If you are looking to rob 5, then you cannot rob 6, then you can rob 7, and you can take both of these values, 10 and 21. You can take both of these values, 10 and 21. So that is how you reduce it to out the house robber problem. You can definitely solve it in the recursion memoization concept that I have told you previously. Let's try to solve it in this way this time. Okay, let's see. Okay. So I have an integer n, which is I will initialize n as 1e4 plus 1. Okay, I will just do that. Now what I will do, I told you to make a separate array, right? It's a map kind of array. So let me keep that as a vector ARR. Okay, that will take nothing but n. Let's take n, and all the values they are giving me 0. All the values are giving me 0. Now what you do, you go from this to nums.size. Remember, nums.size is not n this times. Okay, it's not n this times. What you do is that you go to array, store this nums of I. You say that this element has a value which is equal to this value only, right? Which is plus equal to this value. So what will happen if you have 3 times 5? Let's say you are having in the array, you are having 3 times 5 somewhere in the middle. So what it will do, it will go to the array and store array 5 plus equals to 5. It will do this operation. It will write this thing 3 times in the loop. Okay, 3 times. After doing this 3 times, what it will remain? What will remain in the array of 5 is nothing but it will remain 15. Okay, you add 3 times. So you get that. Now you apply this house robber concept, the same house robber concept in this array vector. You do the DP thing. Okay. How do you initialize it? You initialize it in this way, n plus 1, let's say. Now what you do is that it's simple quite. So you do DP of n. If you have reaching the last house, there's nothing to be robbed anymore. If you are in the last house, then rob the last house. The same thing I am doing here. If you don't know, I am doing the same thing as the house robber problem. And start from the n minus 2, go all the way till 0, I minus minus. What you do is quite simple. dp of I equals to dp of I plus 2 plus this what's is called array of I. You're taking this. If you are taking this, or you are not taking anything, then you go to the next one. Then you go to the next one. That's all. That's all you need to do. You need to maximize the value. You need to maximize the value. That's everything you will do. And then return nothing but dp of 0, starting from 0. So dp of I denotes starting from I, what is the index at which you can loot it, right? So that's all. It should work, I think. Let's try to check if there are any errors or not. Let's try to check it out. So yeah, we are getting a wrong answer. We are getting a wrong answer. Let's try to see what is our error. Okay, so you see what I'm doing is quite silly, is that this is not n-1, this is just array of n-1. Okay, so that's basic. You need to take care of this. If you are in the last house, you either rob that full house only. You have no other choices. You do have to accept it here. Let's try to submit and check. We do have the accepted thing. So yeah, that's all. That's all, I guess. It's linear time complexity only, not very difficult. Linear only. So that will be all. That will be all for today, I guess. From the next video onwards, I may start Knapsack DP or Knapsack. I will either start with Knapsack or I will do Grid DP. Okay. Anyone, either of the one I will do in the next video. So yeah, I think that's all about 1D DPs. I might do some more good problems after learning some more good concepts on DP. I might do some more 1D DP array questions. So for now, for the basics, for grasping the basics, I guess this much is sufficient. We will move to 2D DPs, which is involving knapsacks and grid from the next video onwards. So that's all. Thank you. Thank you so much. Thank you so much.